My channel. Hope you are doing extremely well. So it's our day 23 of solving the GFG POTD series. We have already maintained a streak of 22 days. Okay, so without wasting any time, let's move on to today's problem that says split array largest sum. Okay, so what does the problem say? The problem says you have to minimize the maximum sum possible in a subarray distribution. Focus on in a subarray. Just let me in a subarray distribution. Okay, what does it mean? Suppose you have been given a number, an array as 1, 1, 2. Now, the problem says you have to make, suppose the k given to you is 2. All right. You have to make a subarray distribution. You have to divide the array into subarrays into two subarrays. Okay, two subarrays. Okay. So what are the possible subarray distributions here? It can be I choose no element and all elements. Correct. Then I choose first element, first and second element. All right. Then it can be 1, 1 and only 2. And it can be 1, 1, 2 with empty. Now these two are same. So I will discard one of them. Let's just discard this one. Okay. So what are the sum of elements present in all the subarrays? This will give us 0. This will give us 1 plus 1 plus 2, that is 4. This will give us 1. This will give us 1 plus 2, 3. This will give us 2. This will give us 2. Alright. So the problem says me that I have to divide it into two subarrays such that the maximum sum of a subarray in that distribution is minimum possible. The maximum sum of a subarray in that distribution is minimum possible. So if you see that the maximum sum here for this distribution is 2, for this is 3, for this is 4. So what is my answer here? It is 2. So 2 is maximum in this distribution, but if we look at all the distribution, the maximum sum here is the minimum in among all of the others. Okay, I hope you are clear with the question. What does the question demand from you? Okay. So without focusing anywhere else, let's move on to the brute force approach. So brute force approach also says that think of the most simplified task you can do. It says subarray distribution, create one. So brute force approaches create all the subarray distributions possible. Okay. And secondly, create your answer as required. That is keep it minimum, keep it as minimum as possible. I hope the brute force is very clear to you. Brute force has nothing to God with the understanding. All right. Without wasting any time, let's move on to the efficient only because there are two approaches for this problem which I can figure out. I hope some of you have brilliant minds to figure out a third approach which no one has thought of ever up till now. So give it a try if you can think of any other approach which I'm not listing here. Okay, I'm not able to figure out any other approach. So let us move to the optimized approach. So the array given to us was, let us increase the size of the array. Let us say the array given to us is 2, 3, 4, 6, 8. Okay. Let us try to figure out the answer for this. The possible subarrays are empty. Let us say the k is 3 here. We have to divide 3 subarrays out of it. So first can be empty, then this can contain also empty, then this will be 2, 3, 4, 6, 8. Okay. Now push one element to this. That is, this is empty. This will be 2. This will be 3, 4, 6, 8. Okay. This series will continue up till all of them only one element. Like it will continue till 2, 3, 4, 6, 8. Okay, because the last after this will be the same as this one, so I'm discarding that already. So we have to find this. Okay, my approach says use binary search. Why was I able to conclude that it can be solved with the help of binary search? Reason being that my DSA practice tells me that this problem is very similar to the one of pages allocating pages. Okay, the problem says the same. If dividing the subarrays, what can be the minimum sum possible? Minimum sum. Dividing the subarrays into k subarrays, dividing the array into say k subarrays, what is the minimum possible uh, element that can be present as a maximum sum? With that can be the maximum element in the array, that is 8. 8 is the minimum sum possible for a subarray, because any subarray will contain 8, and if it contains 8, the sum would be greater than or equals to 8. So my minimum now is 8. Okay. And what can be the maximum? In this case, what is the maximum? 2, 3, 4, 6, 8. This is the maximum that can occur in any subarray, correct? So my maximum is currently 2 plus 3 plus 4. That is 2 plus 3 gives me 5. 5 plus 4 gives me 9. 9 plus 6 gives me 15. 15 plus 8 gives me 23. So 23. Okay. I am saying my answer will range from 8 to 23 inclusive. Am I correct in saying that? Yes, I'm absolutely correct. So, what if I run a binary search to minimize my answer? Minimize my how? I say I have got mini as 8, okay, maxi as 23. Now I run a while loop while my mini, that is my starting point, is less than equals to maxi. This is the basic binary search loop, binary search format, right? While my mini is less than equals to maxi, I calculate a value that is mid, which is equals to average of these two, that is mini plus maxi by 2. Okay. I say if this if mid is a possible answer, then what should you do? Then I will first keep a answer as maxi here, because maximum sum is always a possible answer. Answer is maxi here. Then answer will be updated to mid, and then as I have to minimize it, so I will decrement the maxi to mid minus 1. Okay, maxi equals to mid minus 1. Why I'm decrementing maxi and not incrementing mini? Because I have to minimize my sum, and if I will decrement maxi, then only my mid will decrease, correct? Okay. Now if mid is a possible answer, then answer equals to mid and maxi becomes mid minus 1. Else mid was not a possible answer. So if 11 is not a possible answer, we have to check for 13 per se, or 15 per se, or 17 per se, or anything greater than equals to 11. For that, I will have to increment my mini. So my mini will become mid plus 1. The loop will continue until the given condition, and after that we can successfully return our answer. The template is correct. Template, I think you have got the gist of the template, that what is our approach. Okay. Now the problem before us is to evaluate this condition, that how can we determine that if mid is a possible answer. Okay, so let's come down to the example again. Okay, suppose I have to check for a number, let's say 16. I have to check if 16 is a some possible at this. Okay, how will I check? I say keep a count as 0 and sum as 0 in the initial. This count is telling me the number of subarrays, and the sum is telling me sum of elements of subarray of current subarray. Okay, current subarray. What are we doing? We are starting from here, going up till here, and as soon as our sum goes beyond this value, we increment our count and our sum becomes that value. That is, the loop will go something like this for I going from 0 up till n minus 1. Firstly, if ARRI is greater than, let me call this value as mid, right? If ARRI is greater than mid. Now, if any element is greater than 16, in this case, if any element is greater than 16, like suppose if this array could have contained 17, was it possible to maintain a subarray with some less than 16? No, because 17 in any subarray, if 17 will come, the sum will automatically be greater than equals to 17. So 16 was not possible. So in that case, directly return false. Correct. If now what do we have to do? We have to do sum plus equals to ARRI, array of I. Sorry. Let me sum plus equals to, yeah, sum plus equals to the element. Okay. Now there can be two conditions. The sum has surpassed my mid or sum is within my limits. So if sum is greater than mid, that is we have surpassed the limit which we were given. The current sum has gone beyond the mid. That is, we have to decrement the sum, or and we have to increment the count that the newer subarray has started. For in that case, first increment the count that a newer subarray has started, and sum will become equals to ARR of. Okay. The loop will continue and end. Okay. After this, we have to do count plus plus. Why? Because if the loop is terminated, we have not the count does not contain the subarray which was in progression. Are you understanding my point? If the loop has terminated, the count does not contain the subarray which was there in the progression. For that, we have to do count plus plus. Okay. Now, how can we check if this is possible? Now, if count is greater than k, what does this mean? It says that if count is greater than k, we have taken, we, let me change the ink, we have to take help of more than k subarrays to keep our maximum sum as mid. If count is greater than k, then this means that is the subarrays we made are actually greater than k, which cannot be possible. So in that case, return false. Else return true. Okay, else return true. That is, we have made the subarrays within the given k value. Return. I hope the check function is clear to you. Let me try run it for you. So let me try run the whole program. So our array was 2, 3, 4, 6, 8. Okay. We were starting from 8 Our maximum was 23, I guess. Yeah, 2 plus 3 gives 5, 5 plus 4, 9. 9 plus 6 gives 15, 15, 23, right? So our first step says mid equals to 8 plus 23 by 2, that is 31, 15. Yeah, integer division we are doing. Mid is 15. We have to check for 15. How we are going to check? So our array is 2, 3, 4, 6, 8. Function is called, yeah. So my count is initially 0. My sum is initially 0. I'm standing here. Okay. I increment sum to 2. I have to check for 15, right? 2, okay. I comes here. 2 plus 3 gives 5, okay. I comes here. 5 plus 4 gives 9, okay. I comes here. 9 plus 6 give me 15, okay. I comes here. 15 plus 8 gives me 23. Now, as I got 23, I have to increment my count. Count becomes 1, okay. Also, k was 3 here, as you remember, okay. I forgot to mention here. Count is 1, 23, and change it to 8, okay. I comes here, the loop is ended. I see that my count, I have to increment the count now because as you can see, the first subarray was 2, 3, 4, 6, and second subarray was 8. But count is 1. We have to increment the count. So count will become 2. That's why I mentioned count plus plus outside the loop also. I hope you are getting the gist of the my each and every step. Okay, count becomes 2. Okay. We wanted 3. So 2 is less than 3. So our condition is satisfied. So mid can be a possible answer. So our answer becomes 15, and as discussed mini becomes mid minus 1, that is 14. Okay, our new mid is 8 plus 14 by 2, that is 22 by 2, that is 11. We have to check the same for 11. Okay, checking for 11 now. Our I is here, increment the sum. Our I is here, increment the sum. Our I is here, it will be 5, sorry, it will be 9 now. Okay, as I is here, 9 plus 6 gives me 15. 15 is greater than 11, so count plus plus, and sum will change to 6. So first sub array is this. Okay, now I is here, 6 plus 8 gives me 14. Okay, 14 is greater than 11, so this will become 2, and this will become 8. Second sub array is only 6. Okay, and third sub array is only 8. Okay, so count plus plus 3. Now 3 is less than equals to 3. Yeah, condition satisfied, so true. So 11 can also be a potential answer, so it changes to 11, and maxi changes to 11 minus 1, that is 10. Our new mid becomes 8 plus 10 by 2, that is 9. We have to check the same answer for 9. Okay guys, check for 9. I is at position 0, it will become 2. I comes here, it will become 5. I comes here, it will become 9. Okay, I will come here 6, so it becomes 15. Okay, 15 again greater than 9, so it will change to 9. Count plus plus, first sub array is 2, 3, 4. Okay, 6 plus 8 gives me 14, so change it to 8 and increment it. Second sub array is 6, and third sub array will be 8. Yeah, k is greater, count is less than equals to k, so true. So my answer will change to 9, and my maxi will change to 8. Checking for 8 now. So I is here, sum will become 2, comes here, it will become 5, comes here, it will become 9. 9 is greater than 8, so it will change to 4, count plus plus. First sub array is 2, 3. 4 plus 6 gives me 10, again greater than 8, so it will change to 6. Second sub array is only 4, it will change to 2. Alright. Now 6, I is here currently. I, it gives me 8 now. 14, not possible, change it to 8, and 6 will come here, and another subarray is 8. Now if you see, count is 4 right now because 4 subarrays are there. If you see 2, 3, 4, 6, 8, there are 4 subarrays. The maximum permissible limit was 3. So not possible, so return false. If you return false, you see the answer does not get updated. It remains 9 up till now. Okay. Now mini changes to mid plus 1, that is 8 plus 1, that is 9. Now mini is greater than 8. So our inequality fails and we get out of the loop. And at last we return our answer as 9. So the minimum sum of the maximum sum possible in the subarray distribution is 9. This is our answer. Let us analyze the time complexity. So as you can see, we run from 0 to sum. So that will be log sum. Sum means sum of the elements of the subarray. and the operation of checking takes n step, going I from this up till this, so it will be O of n. So it will be O of n, so it will be O of n log sum. And are we taking any space complexity? No, we are not using any data structure to store any elements. We are just doing variables, simple variables, so it will be O of. I hope it was clear to you. Without wasting your time, let's code it down. All right. So yeah, our mini will be initially 0 and maxi will be initially 0. Let us set them up so we can perform our answer. Now for int I going from 0, I going from up till n, I plus plus, mini will be the minimum element, the maximum element present in the array. That will be max of mini with arr I. All right. And now maxi would be sum of all elements. That will be arr I. Now my answer is currently 0. Sorry, maxi. Okay. Now while mini is less than equals to maxi, what we have to do? Calculate the mid equals to mini plus maxi by 2. Okay. Now if check the array for mid, if it is possible, our answer will change to mid and our maxi will become mid minus 1 as we discussed. I don't think there is any what do we say, confusion regarding it. I think we are on the same page. Else my mini will change to mid plus 1. We have to increment our mini. Okay. At last return your answer. This is a template. Okay, this is a binary search. Now we just have to write the code for checking if mid is a possible answer. So as it is returning true or false, so bool check, passing the arguments int arr, int n, int k, int mid. Yeah, our first step was to sum equals to 0 and count equals to 0. What does sum hold? Sum holds the current sum of the subarray and count holds the number of subarray. Now for int I going from 0 up till n, I plus plus, what we are doing, if arri is greater than the maximum permissible value, then straight away return false. Else sum plus equals to arr of I. Okay. Now if sum becomes greater than mid, in that case increment the count of subarrays, count plus plus, and sum will change to the current element, right? After the loop, count plus plus for taking the current subarray into the account. Okay. Now if count is greater than k, that is we have to take more subarrays than permissible, then in that case return false. Else return. This is our approach. Let us see if it is running fine. I think I have not committed any mistake in typing. There should not be any compilation error. There has been a compilation error. K. Okay, I've taken capital K as a. Let us now try for this capital K. Again an error. Check. Yeah, K will be capital here also. Checking now. Running fine for compile and run. Let's try it out for submit also. Okay, working fine. So thank you guys for watching my video. I hope you are doing extremely well. And as you can see, we have completed our 23 days. Okay, it has been a long journey up till now, and it will become longer and more enjoyable. Okay, have a nice day. Thank you.